This review is for AP Stats and CCP Stats, Sinclair course MAT 1450, and this is the review for the midterm. And starting at number 1, it says scientists measured an annual forest loss in square kilometers in Indonesia from 2000 to 2013. They found the regression line forest loss equals 7,500 plus, and then it's 1,021 times the years since 2000. For predicting forest loss in square kilometers from the years since 2000. What is the slope of this line? Well, the slope of the line is 1,021. Say in words what the numerical value of the slope tells you. It says that as years goes up by 1, forest lost, our output, increases because it's a positive slope by 1,021 square kilometers. Okay, if we measured forest loss in square kilometers per year, what would the slope be? Note that there are, okay, we're not doing that one. Just don't worry about that one. Okay, if we measured forest loss in thousands of square miles, what would the slope be? We're not doing that one either. Okay, take that one out of there. Okay, next, true or false? Given a regression line with a small slope, it means that the correlation between the two variables is weak. Okay, no, that's not what it means. A small slope just tells you direction, okay, and the correlation tells you strength, and they measure two different things. So knowing strength does not tell us direction, and knowing direction does not tell us strength. So just because we know that it is just gradually sloped, such as this, does not mean that the correlation is strong or weak or whatever. Okay, so we don't know that. They measure different things. 3. Researchers measured the percent body fat and preferred amount of salt level for several children. It shows that y hat equals 24.2 plus 6.0x, where x is represents the preferred salt level and y the percent body fat. Okay, all right. So the output is body fat. So another way to write it is fat hat equals 24.2 plus 6 multiplied by preferred salt level. Okay, so there's another way to look at it. Find the predicted amount of body fat for a child when a preferred level of salt is 0.6. So all I have to do is plug in 0.6 for salt. So 24.2 plus 6 times 0.6. So I entered 0.6, the salt level, into the calculator, and it gives me 27.8. And that is percent body fat. All right, assume that one of the children surveyed has a body fat of 38 with a salt level of 0.6. What would be the residual prediction error when the regression line was used? Okay, residual again is the error of the value. So if we have a regression line and a value, the distance between them is the actual residual. Now we could be too high or too low. So the residual measures that distance. And we already calculated 0.6. So the prediction is 27.8. Okay? And the residual is equal to the prediction, the real minus the prediction. Okay? Which is y minus y hat. Okay, we have our y hat value, and they're telling us that 38 is the real value. Okay, this is the real, and that puts 38 here, 27.8 here. We subtract those, so, and we end up with 10.2. Okay, so that's our residual. All right, page 2. All right, the following table describes the opinions of 570 people that returned the questionnaire in the survey on their opinion of campus residence quality, high quality, medium quality, low quality. And so we've got two different variables being compared here. They're categorical variables of grade and opinion of the residents. Okay, find the conditional probability of opinions among seniors in the college. Okay, so of opinions among seniors in the college. So that means we've narrowed it down to just seniors. Okay, so we're looking at just the senior category, and if I want the conditional probability, I'm going to take 30 over 160, okay, for low. Again, this is seniors, and this is low, medium, high. and we have 60 out of 160 and 70 out of 160. Okay, and if I just convert those to decimal, which is going to give us a better view, it's going to be around 0.1875, and I double that for 0.375, and 70 divided by 160 is going to be 0.4375. Okay, 0.4375. All right, there we go. Okay, next, is the opinion more likely to be high among freshmen or sophomores? Okay, so here we go. So we're looking at if I know someone is a freshman, what is the chance of it being high? And if they are a sophomore, is it likely to be high? So let's do high among freshmen. Okay, so high among freshmen is 65 out of 110, and high among sophomores is 55 out of 130. Okay, the percents that match up with those, 65 divided by 110 is 59%, and 42%. So freshmen. So it's more likely to be high among freshmen. So answer the question. Okay, if a student is selected at random, find the probability that they're a senior and medium opinion. Okay, so an and question just is in the inside. So senior and medium is 60 out of 570. And that is 11%, okay, or 10.5%. Okay, and since it's a probability, we should do 0.105. That would be the best way to do it, okay? All right, next, find the probability that they're a senior given medium, which means that we're narrowed down to just the medium category, so just these 155 people, and senior in that is 60. Oops, wrong spot. 60 out of 155. And that is 0.387. Okay, next, find the probability that they are senior or medium. Okay, so senior is 30, 60, and 70, and medium includes 40, 30, and 25 on top of those. So if I add up all of those, that's 30 plus 60 plus 70 plus 40 plus 30 plus 25, and that's 255 out of 570. And that's 0.447. There we go. Okay, a call-in poll, again call-in, was conducted by a local radio station, concluded that race would not be an issue in the 2008 presidential election. This conclusion was based on data from 450 calls made by local listeners. The sampling technique used is volunteer sampling. Okay, so volunteer is exactly what they did there because the people have to call in themselves. Problem with that is it is biased towards people with strong opinions. Sorry, bumping it up. Okay, so call-in poll, and that is volunteer sampling. All right, simple random sample would mean they took all the residents, put them in a hat, shook it up, draw out a sum. Stratified random sampling means that we would split off exactly one group that is identical to itself but not necessarily representative of the larger population, and we would want to know about that strata, like females who live in a certain neighborhood between ages 40 and 50. Okay, that would be a very, very specific strata. And multi-stage sampling, we haven't really done much with that, okay, so that's not going to be your answer. All right, an Excite poll is an online poll at poll.excite.com. You click an answer to become part of the sample, so you're volunteering again. One poll question was, do you prefer watching first-run movies at a movie theater or waiting until they are available on home video or pay-per-view? A total of 8,896 people responded, with 1,118 saying they preferred theaters. From this survey, you conclude that Americans prefer, no, this is volunteers, so we cannot generalize. A larger sample size is necessary. That's pretty large, that's okay. The poll uses volunteer responses, so the results tell us little about the population of all adults. True. Movie theaters should lower their prices. We know nothing about that. Okay, so C is the only one that makes sense. Okay, So, a public opinion poll in Ohio wants to determine whether registered voters in the state approve of a measure to ban smoking in all public areas. The researchers select a simple random sample of 50 registered voters from each county in the state and ask whether they approve or disapprove of the measure. All right, so this is basically a multi-stage sample. Here's why. And again, we didn't really go over multi-stage samples, so it's not something that I'm going to assess. Just make sure we understand a couple things. First, when we split it into county, these counties are clusters. We did that, okay? So each county is a cluster. And then within the cluster, you're either going to survey everybody in the cluster, which keeps it as a cluster sample, or within that, you then perform a simple random sample, which is what they did. Now, if you're doing two things, if you're going to do a cluster and then only take an SRS from that cluster, that is called a multi-stage sample. Okay, so it will not be on our midterm, but we did cover clusters, we covered stratification, we covered SRS. Okay, we just didn't combine them together and call it a multi-stage sample. Okay, I toss a penny and observe whether it lands heads up or tails up. Suppose the penny is fair, which means it's 50-50. Every occurrence of a head must be balanced by a tail in one of the 2 or 3 tosses? No, okay. I don't know that. Each toss is independent. If I flip the coin many times, the proportion of heads will be approximately 1/2, and that's the law of large numbers. That is true, okay. Regardless of all the flips, half will be heads, half will be tails. No, we don't know that, and all of the above is no. Okay. Again, short-term data is messy. Okay, so we don't have any guarantees like A and C are implying. All we know is that in the long run, we expect the proportion to come out to 1/2. All right, I roll a fair-sided die. The possible outcomes are 1, 2, 3, or 4, so it's a 4-sided die. Roll a 4-sided die, not a fair-sided, 4-sided die. Depending on the number of spots on the sides of the die that is face down. This collection of all possible outcomes is called what? Well, if you've got a list of everything that can happen, that is a sample space. Okay, for question 10 to 12, assume that event A occurs with probability 0.4, B occurs with probability 0.5, and then they are disjoint events, which means there's nothing in the overlap. Okay, so if they're in the, so here's the general formula we need to know, okay? The probability of OR is equal to probability of A plus the probability of B minus the probability of A and B. Okay, so when they tell us that these are disjoint events, we know that this piece right here is 0. Okay, they also told us that the probability of A occurring is 0.4 and B occurs with probability 0.5. All right, so when I find this, the probability that either event occurs when those add to 0.9, 90%. The probability that both occur, well, is 0 because they are disjoint, okay? So the AND piece is 0. And if A and B are independent events, the probability that both events occur is what, okay? Well, if we are independent, then we can say the probability of A and B is equal to the probability of A multiplied by the probability of B. So that's what we've used to show independence. And if this is the case, we would have 0.4 multiplied by 0.5. So it sounds like they took away the disjoint idea here, and that would be 0.2. Okay, so we'd have 20%. All right, the density for a continuous random variable x has which of the following properties? The probability of any event is the area under the density curve and above the values x that make up the event. Okay. Yes, that's true. The total area under the curve must be exactly 1. The probability of any event must be form x equals constant is 0. Oh, if it's a density continuous random variable density curve, then yes, that is true. Okay, so what the heck? All right, so here we go. Think of a normal curve. That is a density curve. All right, and if I consider the probability that it is greater or equal to 4, then we're looking at this area right here. But the probability of it being exactly 4 is 0, okay? Because if it's a continuous graph, then we're allowed to be 4, we're allowed to be 4.0001, and so on. And we've got infinitely many things here. So this is really like one thing out of infinitely many, and 1 divided by infinity is like 0. So there's no chance of being exactly 4. That's not what we look at. We look at basically how extreme it is and further extreme. Okay. The amount of milk sold each day by a grocery store varies according to the normal distribution, with a mean of 130 and a standard deviation of 12. On a randomly selected day, the probability that the store sells at least 154 gallons is what? Well, we know a mean, a standard deviation, and a value. Okay, our mean is 130, our standard deviation is 12, and our value is 154. And when we say at least, we want to know 154 and up. So we're looking for the area to the right. So I just run the app. And I go to normal distribution. And it is mean standard deviation 1 value. And that is 130, 12, and 154. And the probability to the right of that is 0.022 or 23. There we go. Okay, so we do not do this one. We're going to wait and do this one as we get down into central limit theorem next chapter. Okay, so again, pull this question. That is central limit theorem stuff. Okay, all right, use the following to answer questions 19 and 20. All right, nationwide, the amount charged by doctors for performing a particular minor surgical procedure averages 1,220 and varies with a standard deviation of 300. Okay, so the amount charged by doctors, okay, has an average. So there's our mean and our standard deviation are 1220 and 300. Okay. And find the probability that a randomly selected bill exceeds 1,500. So that's one value. And then down here is going to be the bill is between these two. This is 2 values. So let's do the 1 value one first. So I go to normal. 1 value is 1220, 300, and 1,500. Okay, probability to the right, 0.175. Okay, let's run it again. So now I go normal distribution. I go down to 2 values. My mean was 1220. My standard deviation was 300. And value 1 is 800, while value 2 is 1,300. The value between then is 0.524. Okay. Event A occurs with the probability of 0.1. Event B occurs with the probability of 0.6, and they are independent. Okay, so independent means that the probability of A and B is equal to these two. Okay, so let's do that. Equals 0.1 multiplied by 0.6, which is 0.06. Okay, so the probability that both occur is 0.06. All right, then, okay, here we go. The probability of A and B is 0.7. No. Okay, A and B is 0.64. No. Okay, the OR, probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So now we have 0.1 plus 0.6 minus 0.06. Okay, and that is 0.7. 0.7 minus 0.06 is 0.64. So B. An event A will occur with probability 0.5. Event B will occur with 0.6. And the probability that both occur is 0.1. The conditional probability of B given A is what? Okay. All right. I will not ask this other than on given a table. Okay. So I will draw a table and show you kind of where you would be on this right now. Okay. All right. So we have A and not A. We have B and not B. And we know that we're going percentages, so we're going to go to 1. All right. So pretty much I would not word it like this. okay, I would give it to you in a table form or make it easy to fill out a table. All right, probability A occur is 0.5, which means not A is 0.5. Probability B occur is 0.6, which means it's 0.4 here, okay? And the probability that both A and B occur is 0.1. All right, so I can fill in the table now with the rest of the information. This was 0.4, this was 0. Okay, so the conditional probability of B given A means we're just in A, and B given A is 0.1 over 0.5, which is 0.2. Okay, and 0.2 is the same as 1/5. All right. Okay, next, a manufacturing process produces bags of cookies. The distribution of content weights of these bags is normal, with a mean of 16 ounces and a standard deviation of 0.8. Okay, so I've got a mean and a standard deviation, and find the weight of the bag so that it is in the top 10%. So now I know the area right equals 0.1. All right, let's run it. So I go to the next menu. Okay, and in that next menu, I know the probability, the mean, standard deviation, and probability right. Okay, probability right is 0.1. The mean was 16, and the standard deviation is 0.8. So in order to be in the top 10%, it needs to be 17, basically 17.03 ounces. Okay, an event A will occur with probability 0.5, event B occurs with probability 0.6. The probability that both A and B occur is 0.1. We may conclude that what? Okay, are these two independent? All right, so we know that A and B, we know that they are disjoint. Okay, so first of all, let's go through this. Okay, A and B is 0.1. All right, that if they are independent, so if independent, then 0.5 multiplied by 0.6 equals 0.1. And that's a no. If they are disjoint, which means mutually exclusive, then the and, probability A and B equals 0. That's a no. Okay, so we have A and B equaling 0.1. Either A or B always occurs or none of the above. Okay, so let's figure out if both cannot occur. Okay, so let's look at the or and see if it adds to 1. Okay, so the probability of 0.5 adding with 0.6 subtracting 0.1 equals 1. And that is true, yes. So one of them has to occur. All right, so let's look at it a different way. If I make a table, A, not A, total, B, not B, total, okay, and I do the probability of A is 0.5, which means 0.5 here, and I find that the event probability of B is 0.6 and 0.4, okay, then I need the and is 0.1, okay, which puts a 0.4 here, puts a 0.5 there, and a 0 there. So it's not possible to not have one of the two things, okay, so I have to have either A or B. The not either of them is 0. So there's another way to look at it. So A or B always occurs. What is the difference between an experiment and an observational study? And the difference is a treatment. Okay, and this is where you just observe or you survey. Okay, so you're looking at the way things already are and you're changing something with a treatment. Okay, so you've got a treatment, you've got placebos, you've got controls. All right, that's what makes an experiment, is there's a treatment that you're looking for, what impact that treatment has. You flip a coin and roll a six-sided die. Show the sample space. Okay, so I could have head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. If a coin is flipped 5 times, then find a probability at least one flip results in a tail. Okay, so find the opposite, which means that all are heads. Okay, and the probability that all are heads is going to be the probability a half times the probability half times probability half. So flip 1, flip 2, flip 3, 5 times. Okay, and 0.5 to the fifth is 0.03125. Okay, so that says that not a single head occurred, and now I find the opposite of it. Okay, so 0.03125 is 0.96875. Okay, create a scatter plot for the example below. All right, I can do that. And just so we know how we would do it in a calculator, so I go stat, edit, and I'm going to enter in this data. So 1, 2, 3, 4, 6, 8. Oh, I don't have 3. Okay, now I've got 4, 9, 20, 33, 36. Okay, now I go program, AP stats. I go graphs, scatter plot. And there's my scatter plot. Okay, so generally I would have to pick this out of a list, and that's generally what it looks like. All right, what are the features of a density curve that follows a normal distribution? Okay, the features are area equals 1, it is symmetric, okay, and bell-shaped. It is centered at the mean. The mean equals the median, 68, 95, 99.6 rule. So one standard deviation will encompass 68% of the data, 2 standard deviations from the mean will encompass 95%, and then 3 standard deviations will encompass 99.6% of the data. All right, consider the probability distribution below. All right, create a histogram for the distribution of x. Okay, so I can do that. So 0, 1, 2, 3, 4. Okay, and looks like these are pretty much going by 0.05. So if I go up to 8, I'll be fine. 2, 3, 4, 5, 6, 7, 8. 0.4, 0.3, 0.2, 0.1. All right, and then 0 goes to 0.4. 1 goes to 0.25. 2 goes to 15. 3 goes to 15. 4 goes to 5%. There you go, histogram. All right, find the probability of an x greater than 1. Okay, that's going to be 0.15 plus 0.15 plus 0.05, which is 0.35. Okay, the probability B is found with probability B equals 1 minus 0.05. What is event B? Event B basically is the opposite of 4. Okay, so it's not 4, which means that it is a value less than 4 because all the values essentially are from 0 to 4. Okay, so the values we do have, which would count, would be 0, 1, 2, or 3. Okay, and if you wanted to know that probability, you could just do 1 minus 0.05 equals 0.95. All right, find the expected value for x. That is going to be 0 multiplied by 0.4 plus 1 multiplied by 0.25 plus 2 multiplied by 0.15 plus 3 multiplied by 0.15 plus 4 multiplied by 0.05. So there's the mathematics behind it. And what I would do, hang on, get out of this stuff. Okay, stat, edit. Okay, so I'm going to type in the data and remind you how to do expected value on here. Okay, so I have 0, 1, 2, 3, 4. 0.4, 0.25, 0.15, 0.15, 0.05. So I've got the data in where the values are here and the frequencies or probabilities are there. I now run the program, basic stats, and I go down to L1, L2 are the values and the frequencies. And the next value, x bar, tells me 1.2. So the expected value is 1.2. In a research experiment involving testosterone levels, a researcher recommends splitting the subjects up based on weight. Okay, this is called what? All right, in testosterone levels, splitting the subjects based on weight is called, well, this is an experiment first, okay? So this is blocking. If it were a survey, if we were just surveying everybody, then we would call this stratification, okay? And it is done because to reduce variation. Okay, because we expect variation based on weight. Okay, last one. What would this look like if the experiment on the group of male subjects ran as a matched pair study? Okay, so testosterone level. So if we're going to do a matched pair study, there's a treatment involving testosterone or something that controls testosterone. So if we're going to do a matched pair study, then each person is their own control, or we've got two identical people, as identical as we could possibly make them in the variables that matter, and then one will be the control and one will be the person receiving the treatment. Okay, so if you're going to do this where each person is their own control, then you would have them one time get the treatment and one time get the control or placebo. Okay, now that is one way to do it. So each person could be their own control, where one time they get the treatment, one time they get the placebo. And you should alternate the order and randomly assign, like person one is going to receive treatment and then placebo based on a coin flip or something like that, where each person, the order in which they do these is going to be randomly assigned. Okay. Second way to do it is to take two identical people, and person one receives the treatment, person two receives the placebo, and then you compare them, and that's it. All right.